Okay, right. So, hi once again. I'm Professor Indong, right? You can all call me Ma'am Rosc. And I will be the one delivering the lecture on the shoot system. There will be a lot of organ and organ system discussion when it comes to the shoot system because the shoot system consists basically of the stem, the leaves, and the reproductive parts of the plant, which would be your flowers, the fruits, and the seeds. So there are three parts of discussion on the shoot system. So for this particular video lecture, we're going to dwell on the stem first. Okay. So the lecture will go in such a manner that we're going to discuss the external structure of the stem, and then we'll go into the internal structure of the stem. Basically giving emphasis on the layers of the tissues that can be found inside the plant body or inside the stem of the plant. And then we're going to move into the function of the stem and the different types of modified stems. So that's how discussions on the root also happens. And so basically, ganun lang yung gagawin natin so you all can follow. Now, it is imperative that you already know the different types of tissues and the different types of cells that are found inside the plant body because we're not going to dwell on discussing these different types of cells. So I'm just going to be mentioning parenchyma, collenchyma, sclerenchyma, and you should be able to actually imagine what I'm talking about. Okay, so to begin with, right, for the shoot system, as I mentioned earlier, we're going to start with the external structure, right? So the external structure of the stem is basically kung ano yung nakikita natin from the outside, right? So you can see the axis, the main axis of the stem, and then you will see, of course, the leaves, but we're not going to talk about that. Rather, we're going to talk about the attachment of the leaves on the stem and the buds that can actually be found in the stem. So we're going to be talking about basically just the main axis of the plant and not the leaves, as appendages, right? So these are the different parts of the external structure of the plant that you're going to see. So you have the nodes, you have the internodes, the leaf axil, and different types of buds. So when you see nodes, when you say nodes, basically these are the regions where you will find the leaves attached, to the stem. So if you're going to observe a plant body, you're going to see most of the time this expanded region, right? So if there's a stem, it is a little expanded in that area, and there is where you will find the leaves attached to the stem. Later on, we have a diagram to show this just to help guide you. Imagine everything. And then in between two nodes, right, there is an elongated, right, or a certain space, right, that is occupied by this part of the leaf, part of the stem, which we call the internodes. Okay, so this is the elongated portion between succeeding nodes, and internodes actually differs in length in different species of plants. For example, plant types that exhibits the rosette type, as we call it. Okay, so rosette plants, right? We call them rosette plants. Rosette plants are actually those plants that forms a rose or flower-like morphology. Okay, so just so you can imagine an example of this, the best example of this would be cabbage, right? Or the ice lettuce, okay? Or cauliflower, broccoli. So these are rosette types of plants. Unlike other plants, their internodes are actually very, very, very short. And this is the reason why they form this rose-like feature. That's why they're called rosette, or like a flower, like morphology, okay? And external structure, right? So their internodes are actually very, very short, medyo patong-patong. If you're actually going to open, or cut into half a cabbage, you will notice that their leaves are arranged, one on top of the other almost, because they have very, very, very small stems. So internodes, right? The length of internodes actually varies depending on the plant type. Okay. Leaf axial. Leaf axial is basically just the angle between, as is stated there, the stem and the point of leaf attachment. I will show that in the figure to follow. Okay. And then we have the different types of buds. Okay. So these are all buds. Basically, they are young, immature tissue that will give rise to either a leaf or a flower. Okay. So the only difference between these buds will be the region where they are found. So if the buds are found in the leaf axial, then it's called axillary buds. If the buds are found below, the point of attachment of the leaves, right, on the stem, then you call that the lateral buds. Okay, and then if it is found on top of the stem, then you call that the terminal buds. Now, all these buds are covered by bud scales. So bud scales are protective in nature. So they surround the buds to protect the growing, the tissue, right? Or the growing organs, right? Within the buds, okay? So, or inside of those buds. So these bud scales are actually highly cutinized, right? So they are highly cutinized and lignified. Okay, so these bud scales, right, are highly cutinized and they are highly lignified. Okay, so let's clear that so we can move on to the next slide. Right, so here you're going to see the whole plant body, right, where we have the root system. Of course, we're not going to discuss that in this particular video lecture. We're just going to focus on the whole shoot system. So we have the leaves, right? You can see the leaves in here, but of course, we're not going to discuss the parts of the leaves because that would be part of the discussion for the next video lecture that you're going to receive. So you will notice here that this is the leaf and this is the area of the point of attachment of the leaf. And this area where the leaf is attached, that's what we call the node. Yeah? So this is one node, right? This is another, okay, that's another, and then here we have another node, here we have another node. Now, the area in between two nodes are what we call the internodes. So here you have a very long internode, there you have a shorter one, because this is a younger part of the plant, so medyo shorter internode, right? In older parts of the plant, you will notice bigger or longer internodes. Okay, so that's your internode. And then, as I mentioned earlier, okay, so this is your node, all right. So this is the main axis of the stem, and this is your leaf, right? So there is an angle in here, and that particular angle, right, is what we call the axillary, the leaf axial, sorry. So you have the leaf axial, okay? Oh, nawalan tayo ng tinta. Okay, so this is what we call the leaf axial. Okay, so that particular angle, yung leaf axial. Okay, so that particular region. So the leaf axial is basically just the point, no? It's the point of it's just a region wherein the base of the attachment of the leaf and the stem actually meets. So if you find, right, nodes that are located sa leaf axial, then you call them your axillary bud. However, nodes that are found at the tip, normally we call that the terminal bud. Or another term, as you can see here, would be the apical bud. Okay? So if a bud is found, gaya ng sinabi ko kanina, underneath, no? Over here. So if the bud is found over here, underneath the attachment of the leaf, okay, doon sa node, doon sa stem rather, attachment ng leaf doon sa stem, if the bud is found under there, then you call that the lateral bud. So this will be the area where you will find a lateral bud. Okay, so the difference sa mga buds na ito would be just the location where you can find them. And of course, you call a bud a foliar bud. Okay, this is just another term that you will notice. Foliar means it's leaf, no? So a foliar bud will give rise to a leaf, and then you have a floral bud. A floral bud will give rise to a flower. Okay, so basically all buds are the same in their tissue structure and in the bud scale covering that they have. The only difference that gives them their different names, of course, is una, saan sila makikita? Is it an axillary bud? Is it a terminal bud? Or is it a lateral bud? And of course, what are the derivatives that can be formed from them? When you say derivatives, it means ano yung resulting tissue or organ, right, that will be found from them. Okay, so foliar if the bud gives rise to a leaf, floral, no, foliar bud if it's giving rise to a leaf, floral bud if it's giving rise to a flower. Okay, so those are the different terms, no, that you have to know when it comes to the buds, and of course the different terms that you have to know when it comes to the external structure of the stem. Now going into the internal structure, still on the external structure, there are different types of branching patterns, no, of plants. Here we are also giving you an example of a branching pattern that can be found in lower vascular plants. And that is basically the dichotomous branching pattern, where you will notice two equal branches arising from the tip of the stem. Okay, so once again, I will give emphasis on this. Dichotomous branching pattern is a primitive branching pattern that can only be seen in lower vascular plants. Okay, in higher vascular plants, hindi natin nakikita ang dichotomous branching pattern. Now, before we even go to the dominant type of branching pattern in higher vascular plants, there is another branching pattern that actually evolved, no, from the dichotomous branching pattern. It is a more advanced evolution of the dichotomous branching pattern, and we call this the Pseudomonopodial branching pattern, where there are also two branches that arose from a tip, but one of the branches became more dominant than the other. You will notice the difference later on in the figure to follow. Okay, so Pseudomonopodial is also not found in higher vascular plants, and they are found mostly in lower vascular plants, but Pseudomonopodial is a more advanced evolution of the dichotomous branching pattern. Okay, and then of course we have monopodial. So monopodial branching pattern is the one that is dominant in almost all higher vascular plants. Okay, so monopodial branching pattern is that particular branching pattern you will see where one stem dominates all the branches. Okay, so there is one stem, and that particular stem basically becomes the axis, the main axis of the plant, and then you will just see different branches coming out of it. Okay, so this is the figure that shows us the different types of branching. Okay, so we have here the dichotomous branching, right? So here we give emphasis to the apical meristem. So that is the tip that we were talking about earlier. From that tip, when two branches, right, arise, and these two branches grows equally, no, with not one dominating the other, then we call this the dichotomous branching pattern. And this is highly seen in lower vascular plants. A more advanced but still primitive form of branching pattern is the pseudomonopodial, where you will see or you will notice that just like dichotomous branching, there are two branches that arose from the tip, no, or the apical meristem. However, instead of growing equally, right, one of the branches actually dominates the other. Okay, so one of the branches actually dominates the other, and so this is why it's called pseudo or false, no, or the false version of the monopodial type of branching. Okay, And then we have, of course, the most evolved one and the one that is seen in higher vascular plants. We have the monopodial branching pattern. So these two are actually monopodial branching pattern, wherein you will see one dominant branch, right, that becomes the main axis of the plant. Okay, the only difference between these two is how the rest of the lateral branches are actually arranged on the main axis. So here you will see doon sa term, right? We have alternate branching, and here we have opposite branching. So alternate is because we have one branch here. The next branch you will found on the other side, but not opposite, no, the first branch. So that's what we call alternate branching. Opposite branching, however, is a type of branching where you will find two branches, no, opposite to each other on the same point, right, on the stem. So that's that. And basically, that's that for the branching patterns of stem. Okay, so that ends our discussion on the external structure of plants. Okay, finish. All right. So moving on to the internal structure of plants. So what we're going to do here is we're going to discuss first the primary state of growth, and then followed by the secondary state of growth. Now, before we even go into details on this, what I want you to understand is all plants during their initial state of growth, they are all in primary state of growth. And then they will undergo a secondary state of growth, which will facilitate giving them more years. Primary state of growth is mainly responsible for the elongation of plants vertically. Secondary state of growth is responsible for giving plants more gears. So there it's growth laterally. Okay. Now, not all plants undergo secondary state of growth. Secondary state of growth will always give rise to wood. Okay. So any plant that undergoes secondary state of growth will become woody. Therefore, those plants that do not become woody from when they grow to when they die, they will never undergo secondary state of growth. So monocots, right, mostly, right, do not undergo secondary state of growth. Some dicots do not undergo secondary state of growth, like the herbaceous dicots that we have. Okay. However, most dicots, right, undergo secondary state of growth, and these dicots are what we call the woody plants. Okay. So there are dicots that do not undergo secondary state of growth, but most of those plants that undergo secondary state of growth are dicots. Okay, most. All right. So the whole idea of this will be supplemented by your laboratory, where you will see most of the examples that you have for studying wood or woody tissue are actually dicots, right, in nature. Okay, but all plants, of course, undergoes the primary state of growth, because without this, they will not elongate. All right. So in this particular discussion, we are talking about structures. No, so structure. So we will give you mainly layers, right, of the plant, right. So you are going to be reintroduced once again to the tissues that you've already heard in the previous discussion of plant tissues. Okay. So for the plant's primary state of growth, what we're going to see mainly, right, and number one, that is also most responsible for the elongation of a plant or the vertical growth of the plant would be the shoot apical meristem. The shoot apical meristem is more famous, no, for the term SAM. Okay, we call it SAM, shoot apical meristem. The shoot apical meristem is the region of the plant at the tipmost part, no, that is highly responsible for elongation of the stem and formation of the leaves and flowers. Okay, so the shoot apical meristem is responsible for the vertical growth of the plant. If you snip the shoot apical meristem, the plant will stop growing. As long as the shoot apical meristem is alive and intact, the plant will never cease to grow vertically, no, or grow upward. Okay, now there are different types of tissues or cells found in different levels, or in different in different levels of plants. Okay, so lower vascular plants actually contains cells, which we call the apical cell, okay, found in their shoot apical meristem. And the apical cell is basically characterized by one cell giving rise to all tissues of the plant body. There is one cell that gives rise to all tissues of the plant body. In higher vascular plants, you will not see this. In the shoot apical meristem of higher vascular plants, you will see a group of cells, right? At the outermost layer, there's a group of cells that basically gives rise to the rest of the cells that are needed to form the rest of the plant tissue. So when it comes to shoot apical meristem, a shoot apical meristem can be consist of either an apical cell, okay, characterized by one cell giving rise to all tissues and cells of the plant body, and an apical initial. When you say initial, the term initial pertains to meristematic cells, but it's a group of cells. No, when you say initial, this is a group of meristematic cells, which means it is highly dividing. No, so it gives rise to new cells. Okay, so a shoot apical meristem can be characterized having an apical cell or having an apical initial. So for our guidance, those that has apical cells are actually lower vascular plants, and you will not see apical cells in higher vascular plants. Rather, what you're going to see is apical initial. Okay, so let's just make that clear. Now, the apical initial layer, you will see later doon sa ating figure. Okay, so in this particular figure, I just want to show you where you can find the shoot apical meristem. The shoot apical meristem is actually just this area over here. Okay, the reason why I showed in the first figure this whole figure is because I want you to know where to find it and how it looks like. So this is the main axis, okay, of the stem, and at the tipmost of the main axis is where you will find the shoot apical meristem. So when we were in college, we call this particular part Batman, because whenever we are asked to draw the shoot apical meristem, it looks like Batman, you know, with the leaf primordia that almost covers it. But okay, the shoot apical meristem is actually just this area. So if you zoom in from this area, it basically looks like this, right? So if you zoom in from that area, it basically looks like this. And the shoot apical meristem is just this. You will notice this area where you have very, very, very dense cytoplasm, no? Cells with very dense cytoplasm, and those are actually part of the whole shoot apical meristem. Now, the outermost layer of the shoot apical meristem is where you can find, no, ito pinakalabas is where you can find the apical initial. It is highly dividing, and it gives rise to new cells that you can see here, okay, and here, and all of that came from the shoot apical meristem. Okay, so once again, the shoot apical meristem is just this mound. It is actually this mound, this area where you can see this highly dense cytoplasm of cells, or the cells with highly dense cytoplasm. That is your shoot apical meristem. Okay, so however, when we draw the shoot apical meristem, normally sinasama namin itong buong area na ito, right? Because the leaf primordia that is covering it is normally kasama within the slide, right? But if you're going to identify the actual tissue, the actual shoot apical meristem region, it is just this. This is where the whole meristematic tissues are found. And the apical initial, because this is an example of a vascular, higher vascular plant, the apical initial is the outermost layer over there. Makikita niyo. Okay, it's a bit difficult to differentiate here because it looks like all the cells are overlapping because of the dense cytoplasm. Nevertheless, right, this is a very, very good figure, right, to introduce you to the shoot apical meristem. Okay, now just right below the shoot apical meristem, a little farther down, right, from the shoot apical meristem, you will find the primary meristems. The primary meristems, as far as I know, should have been discussed sa discussion ng tissues, so you should be very much aware of this. Now, we're just discussing where you can find the primary meristem in the stem because, you know, it is imperative that we know. Okay. So the primary meristems, as you all know, would be the protoderm, Okay, the protoderm, the ground tissue, or the ground meristem rather, and the procambium. So these are the primary meristems. We all know that the protoderm will give rise to the epidermis, which we will also discuss later. The ground meristem will give rise to the ground tissue. Okay. Nakita na ninyo sa PDF ninyo na meron akong face of primary meristems, no? So you will see all this. And then the ground tissue, basically, depende kung nasaan area siya, no? The ground tissue can be classified as either a cortex or a piece area or tissue. I will give emphasis on that mamaya sa mga examples natin. And of course, you have the procambium, and the procambium is a primary meristem that gives rise to vascular tissues. Vascular tissues would be your xylem, or the plants, because you don't have xylem, and phloem. Okay. So yan, pasensya na po sa sulat, right? Medyo mapangit, right? I'll try to write a bit better. Okay, and so these are your primary meristems, and itong mga sinulat natin would be the derivative, right? Once again, ano yung derivative? Resulting tissue, okay? This would be the derivative from these three particular primary meristems. Okay, now the primary meristems actually can be found somewhere around this area. Okay, so it's basically around this area. Okay, so in this region, you can find your primary meristem. So, as I mentioned earlier, yung mound, no? Yung mound natin would be our apical meristem. Lakihan natin ang konti. Okay? So, the mound would be your apical meristem. A little below it, right, in this region, you will find the primary meristem. So, from the outside, right, you have the protoderm. Going inside itong area na ito, as well as this area, right? Yung lighter yellow areas. And of course, the lighter yellow area here, that would be your ground meristem. Okay? So, kung makikita ninyo na nakaayos ng ganito, yung procambium, right? We can determine a cork and a piece, no? So, the ground, pero nasa ground meristem pa lang tayo, so later on na natin yung sabihin. Okay. In any case, ulitin ko lang, the outermost part would be the protoderm. These are highly elongated cells, no? So from small, highly dividing cells that will become protoderm will start to elongate. So basically, the primary meristems are derivatives of apical meristems, pero they change in their shape, the density of their cytoplasm, right, and their sizes. Yung protoderm, they become elongated. Okay, so they become elongated, right? The ground meristem, iburahin ko lang. Oops. Sorry about that. Ayan. Okay, so the protoderm becomes elongated, right? The ground meristem becomes highly vacuolated. Oops, yun ang nagkasya. Okay, and then, well, the procambium, basically you're going to see this as more of a strip. It's not, it doesn't actually look like that. It looks more like a strip of tissue, no? It will give rise to phloem and then xylem eventually. All right, so these are some of the changes that happens to the cells of the apical meristem that gives rise to the primary meristem. So this is the region, once again, this is the region where you can find, okay, the primary meristems. It's a little below, okay, a little below the shoot apical meristem, okay, but it is not super low, no, hindi siya sobrang baba, because the rest of the plants in this area are in the maturation region already. And maturation region basically consists of the primary tissues, right? So these are tissues that are highly differentiated, which means they already have a fixed function for the plant. Okay, so that's that for the primary meristems. So natapos na natin si shoot apical meristem from the very top, and then a little down below, we have the primary meristem. So going to the maturation region, we have the primary tissue. Okay, so if we have protoderm, ground meristem, and then procambium, ganun din yung magiging discussion natin basically sa primary tissue. So we will start with the epidermis, that is from the outside. Okay, so you're already given here some of the attributes of the epidermis. So the epidermis is the derivative of the protoderm. Okay, it is the outermost protective layer of the stem. Okay, that is the main function of the epidermis, and it is usually one cell thick. However, right, some epidermis are actually consist of more than one layer. And if it is consists of more than one layer, we normally call it multi-serrated or a multi-serrate epidermis. If it's just one layer thick or one cell thick, it is what we call the uniserrated epidermis. Okay, and normally epidermis are actually just one cell thick. Most of the multi-serrated or multi-serration, no, yung more than one cell layer of epidermis is actually highly species specific. Okay, now the epidermis also bears what we call the trichomes. So this should have been introduced to you sa inyong discussion on tissues. Trichomes are epidermal appendages. Okay, which means from an epidermal cell. So epidermal cells are normally elongated cells, no? So they are normally elongated cells. So from them, kapag nagkaroon ng growth, right? Okay. So nagkakaroon ng okay. So nagkakaroon ng outgrowth from the epidermis, and these outgrowths are what we call trichomes. So iba-iba yung itsura ng mga trichomes na yan, and this should have been discussed sa inyo, right? Sa discussion on tissues. So these trichomes also has different functions. So mostly protective, you know, from desiccation, right? And some of them are actually anti-herbivory, you know, and all this. So there are different types, different morphology and different function, of course, ng mga trichomes. Nevertheless, you have to remember that trichomes are actually appendages, right? That are coming from the epidermis or an epidermal cell. It's an outgrowth from the epidermis. Okay, now the epidermis also secretes cutin that basically forms the cuticle. Now, gaya ng sinabi ko kanina, elongated cells ang epidermis. And from these elongated cells, normally, if you zoom in, no, using a high-powered microscope, you're going to see a transparent layer on top of it that looks like this. No? So hindi siya polygonal. It looks more like humps. No? And these are actually waxes and cutins. They are protective layer of the epidermis that protects the plant from desiccating, no? Para hindi lumalabas lagi yung water, because of course the stem is exposed to the outer environment. Okay, and as was mentioned earlier, it can be one layer, one cell thick, which is uniserrated, and or could be more than one, and we call this multi-serrated epidermis. Okay, so this next slide basically shows you a cross-section of a monocot. So this is monocot, okay, a monocot plant and a dicot plant. So the monocot plant, right, is characterized, well, why we know this is a monocot plant without any labels, I will tell you later, right? But what I want you to notice, right, mainly is the epidermis, okay? So In the monocot plant, this is the epidermal layer. Medyo putol siya dito. No? You can see that dark outline area. That's the epidermal layer. In the dicot plant, it's, okay, burahin muna natin yung sulat. It's this layer. Sorry, nahirapan si Madam. Okay. Why am I in eraser phone? Okay, it's this layer over here. Yan. Yung layer na yan. Now, this is, syempre, dahil photo ito, pag nag-zoom in tayo, I'm zooming in a different monitor. Ayan. So, pag nag-zoom in tayo, hindi nyo masyadong makikita yung separate cells, no, that can be seen in the layer. But this layer, yan, that particular layer is the epidermis of this dicot plant, and this particular layer, the dark one, is the epidermis of this monocot plant. Okay, so yung outermost layer na yon, and like I said earlier, I keep pinching on the wrong monitor, sorry. Like I said earlier, it is normally just one cell thick. So you know kung nasaan yung boundary or yung line, no, that actually tells you where the epidermal layer is. So that's the epidermis. Okay. And then after the epidermis, going in, we have the cortex and the pith. Okay. As I mentioned earlier, depending on the region, pwede kang magkaroon sa isang plant ng cortex and pith, or pwedeng wala. Okay. How is that? Before we go there, right, i-discuss muna natin kung ano yung characteristics ng cortex and pith. Now, cortex and pith are derivative of the ground meristem, as I mentioned earlier, and it is mostly made up of parenchyma cells. Sometimes you can see collenchyma and sclerenchyma cells present in the cortex or the pith, and this is normally because the plant requires additional support. Okay, so makikita nyo ito sa mga halaman, like for example, celery. When you bite sa celery stem, right? There is this parang mas matigas na fiber inside it that you actually cannot chew, right? So those are mostly collenchyma in nature, and they are there for support. Okay. So cortex, ang cortex and pith. Now, in lower vascular plants, right after the epidermis, you will notice a second layer, no, which is derived from the ground meristem. So basically, this is a ground tissue. No? So ang cortex and pith, we call them, right? All together, we call them ground tissue. The tissue that consists the cortex and the pith, we call them ground tissue. Dahil nanggaling sila sa ground meristem. You will all know which is the cortex and the pith depending sa location nila, no, inside the stem. I will elaborate on that later. So, yung ground tissue ng lower vascular plants, yung outermost layer ng ground tissue is actually specialized into an endodermis. So sa lower vascular plants, so ulitin lang natin ha, sa lower vascular plants, okay, right after the epidermis, when you go into the ground tissue, the outermost layer of their ground tissue is actually consists of cells that basically makes up the endodermis. Now, in higher vascular plants, right, you will never find an endodermis. You will only see this the roots, okay, because the endodermis is actually found in the roots of higher vascular plants. But in lower vascular plants, there is an endodermis that can be found in their stem. Okay, so ulit, endodermis is found in lower vascular plants. In higher vascular plants, you will not find them, but some plants, not all, some plants also has this specialized outermost layer of their ground tissue, which we call the starch sheath. Okay, the starch sheath, as the name suggests, contains starch. So not all plants, not all stem actually has a starch sheath. Okay, starch sheath contains cells that can store starch. And storage of starch is not normal for stem of most plants. Okay. Now, those that contain starch sheath are actually storage stems. No, stems that has a specialized function of not just support and not just translocation of nutrients, right? And food ng plant, but also storage, right? Kasi yung starch is a storage form of carbohydrates para sa mga halaman. Okay? Now, the starch sheath in woody plants or woody dicots are also called differently. So there's a different term for the starch sheath of woody dicot, and we call that the medullary sheet. So the medullary sheet is basically the same as the starch sheet in the sense that it can be found right after the epidermis at the outermost layer of the ground tissue, no? But the main difference is it can only be found in woody dicot, right? And it has more starch and it persists longer than the starch sheet. Okay, so basically that's the ground tissue or the cortex and the pith. Now, gaya ng sinabi ko kanina, you can differentiate a cortex and a pith. Depende sa kung saang region sila makikita. And you can only have these two regions, no? Basically, with clear distinction kung saan sila makikita if you have what we call the vascular cylinder. What is a vascular cylinder? As the name suggests, okay, vascular cylinder consists of vascular tissue. Ano ang vascular tissue? Xylem and phloem. And it is arranged in a cylindrical manner. So ito, this is one vascular bundle. Okay, so ang tawag natin dyan ay vascular bundle. Okay. LE, right? A vascular bundle that is arranged in such a way that it looks like, no, it forms a cylinder is what we call the vascular cylinder. Okay. So in this dicot cross section, we have a vascular cylinder. Clear it up. What happened? Okay. Okay. So in this dicot cross section, okay, dicot cross section, we have a vascular cylinder. Nakikita niyo yung bawat isang vascular bundle naka-arrange siya cylindrically. Right? Therefore, yung ground tissue mo, right, na makikita inside, the ground tissue that is found inside the vascular cylinder basically is the area that we call teeth. Okay? Now, the rest of the ground tissues that are here outside of the vascular cylinder is the area that we call cortex. Okay. So if we are going to call the tissue the pith, you know that there is a vascular cylinder and it is found inside the vascular cylinder. Okay. If it is outside the vascular cylinder, but it is a ground tissue, you call that tissue cortical tissue or cortex. Okay. Now, unlike the dicot cross-section, nakikita natin, no, stem, right? The monocot stem do not have this clear delineation of regions of the pith and cortex. Why? Because unlike the dicot, you will notice that the vascular bundle, no, of a monocot is arranged highly randomly all throughout the inside of the stem. Okay, so that there is no one particular vascular cylinder that is formed. And since highly scattered ang vascular bundle ng monocot, there is no piece and there is no cortex pagdating sa monocot. So what do we call the tissue that are not forming the epidermis and not forming the vascular bundles and are actually derivatives of the ground meristem? We simply call them the ground tissue. Okay. So the piece and the cortex are also both ground tissues. Ulitin lang natin. Ground tissues are derivatives of ground meristem. The piece and the cortex are both ground tissues. The only difference between these two is where they can be found. And since in monocot stem, there is no vascular cylinder, therefore there's no delineation, right, of an area of a piece and cortex, then you can never designate a piece and a cortex or a piece and a cortical area in monocot stem. So instead of calling them piece or cortex, we just simply call them the ground tissue. Okay, so that's that basically. All right, I hope that's clear. If you have any questions regarding that, you can clarify that to your professors. Okay, and so after ng ground tissue, so kanina, di ba, we have the protoderm. Okay, the protoderm gave rise to the epidermis, and then we have the ground meristem, and that gave rise to the ground tissue. Okay, so the ground tissue can either be cortex or piece, no? In some, right? In some plants, mostly in dicot plants, right? In monocot plants, we just call them the ground tissue. So dahil nabigyan na natin yung derivative ng dalawang primary meristems, now we're down to the last, and this is the primary vascular tissues. Okay, so the primary vascular tissues are your primary xylem, okay, and your primary phloem. Why primary? Dahil meron tayong secondary xylem and secondary phloem. Okay, so as was mentioned earlier, this is the derivative of the procambium. Now, it is imperative that we know, right, yung behavior, right, or yung attribute ng xylem maturation. By xylem maturation, it means saan naunang napoproduce na area yung xylem, right, and paano yung growth niya, no? Saan yung direction ng growth niya. Okay, so xylem maturation in stem is different in xylem maturation ng roots. Okay, so pag napanood nyo na yung video lecture nyo on roots, you will know that xylem maturation of roots is centripetal, no? It is endarch. It means from the outside paloob. Okay, yung formation ng kanilang xylem. Sa stem, ang xylem maturation is endarch. Endarch is characterized by a centrifugal. So from the axis palabas, right? Na formation ng xylem. That means yung mga protoxylem are the very first xylem tissues or xylem cells that will be formed, no, during xylem formation. The protoxylem and the protofloem, so ganun din sa phloem, yung mga unang phloem naman na magpo-form, they are found mostly near the axis, no, near the main axis. And then, after ma-form ang protoxylem and protofloem, as xylem cells and phloem cells are produced, dahil centrifugal ito, palabas, the metaxylem and metafloem, those are the next xylem and phloem cells to be produced after ma-produce ang protoxylem and protofloem. Okay? The metaxylem and metafloem, right, are produced towards the outside. Okay? So towards outside. Okay, so metaxylem and metafloem. So yung formation nila, pag na-form yung metaxylem, right, in towards the sa near the axis, the next formations will be palabas. Okay, so nasa labas. Right, so what's the difference between protoxylem and metaxylem? Number one, kung kailan sila na-form. So protoxylem are formed first. Okay. Formed first. And they are bigger. Okay. Metaxylem are formed after the protoxylem and they are smaller cells. Okay. Ganun din yung protofloem and metafloem. All right. Now, in this next slide, we'll go back to that. In this next slide, I want to show you yung itsura ng xylem, right? Protoxylem, protofloem. Okay? So it is seen best here, yung metaxylem and protoxylem and metaxylem. Okay? So what you have to remember is, right, if you have the stem, okay, the procambium will be these sheets, okay? So mga mukhang malalabong area na to. Those are the procambium, right? So strips sila, di ba? Sinabi ko kanina, strips sila. So yung mga procambium na yan, it will always give rise to xylem inside, phloem outside. Always, kahit dito, okay? This is xylem, that is phloem, right? This is xylem, that is phloem. Laging xylem inside, phloem outside. Ang formation ng vascular tissues. Okay. Now, notice that the vascular tissues, okay? So, bawa ito. Ayan, mas malinaw ito. This particular xylem, right? The metaxylems, the ones that are bigger, right, are formed near the axis. Okay? Bakit yun yung axis? Kasi yung axis natin basically will be the procambium. Yun yung main axis. Right? So from that, mas malapit doon mapo-form ang mga protoxylem and you will notice, okay, you will notice, right, they are bigger. In comparison to these cells, yung mga cells na nandito, which are basically the metaxylem. Okay? The smaller cells, right? The smaller xylem cells are the metaxylem. Okay? The bigger xylem cells are the protoxylem. Ganun din sa phloem. Medyo mas maliliit na lang ang phloem in comparison to xylem. So it's a bit difficult to see here. So siguro puntahan natin ito. Right? This is also a monocot. This is a monocot tissue. Right? So if we look at, say for example, this phloem area, right? So itong dalawang mukhang mata na ito ay xylem, right? So this area, yan, that is the phloem area. And you will notice that ito yung main axis natin, no? Nandito si procambium. These are your protofloem. And the smaller ones over here are your metafloem. Okay? So, from the main axis towards out naman, ganun naman yung kay phloem. Right? Ang outside ni xylem is medyo towards sa loob ng plant cell. Okay? Because we are pertaining to the main axis as yung ating procambium. Okay, so that is xylem maturation, characteristic ng stem. Right? So, mapapansin nyo pag napanood nyo na yung video lecture nyo sa roots, this is medyo baligtad ng konti. Okay, now stems with secondary growth, basically, yung kanilang procambium ay nawawala, right? In such a way that the procambium turns into what we call a fascicular cambium. So, from the transition from procambium to a fascicular cambium, there is a point in time when the procambium is called the residual cambium. Okay, so yun lang yung gustong sabihin nung slide na ito when it comes to the residual cambium. Later on, I will, there is no discrete time kung saan makikita mo si residual cambium. All we know is, if the plant is not yet undergoing secondary growth, nasa primary growth siya, the area where you can find the procambium remains the procambium. That same area, that strip of tissue, as the plant transitions into secondary form of growth, nagiging residual cambium siya, and eventually it will turn into a fascicular cambium, which is normally the same region with the same cells, but this time it will give rise to secondary xylem and secondary phloem for those plants na mayroong secondary growth. Okay, so we'll give more emphasis on that pag nasa secondary growth na tayo. Okay, so we are clear now with the primary vascular tissue, xylem, phloem, xylem in the inside, phloem in the outside. They are actually derivatives of the strip of cell known as procambium. And their formation, the formation of the protoxylem and the metaxylem actually follows the endark na pattern. Now, when it comes to the arrangement, okay, the arrangement of the vascular bundles within the cortical, within the ground tissue rather, not the cortical tissue, within the ground tissue, the arrangement of the vascular bundles are actually called stellar patterns. Okay, stellar patterns. And there are different types of stellar patterns in, of course, both lower and higher vascular plants, and also different in higher plants in that it's different from dicot and different from monocot. So we have here the basic stellar patterns because there are more types of these stellar patterns. Okay, so we have here the basic stellar patterns. We have Siphoning still, U-still, and Apical still. Now, Siphoning still is a stellar pattern that is seen in lower vascular plants. Okay, in lower vascular plants. Now, U-still and Apical still are seen in higher vascular plants. Okay. However, U-still is a characteristic stellar pattern of dicot. Okay. Nabusan ng tinta yung ballpen natin. And Apical still is, of course, characteristic stellar pattern of monocot. Okay. So we'll discuss that more in this next slide, right? So this particular stellar pattern that you will see here is the Siphoning still. Siphoning still. Right? Stellar pattern. The Siphoning still stellar pattern is characterized by the vascular cylinder, right? Surrounding completely, okay, a piece in the center. Okay? So dito makikita nyo, right? This is the xylem, and there are 2 layers of phloem. Okay? Right? And the whole piece is surrounded completely. Okay. Now, Siphoning still is not found in higher vascular plants. So, punta tayo dun sa dalawang nasa ilalim. Right? These are the stellar patterns that are mostly seen in higher vascular plants. So, this is the U-still stellar pattern. The U-still stellar pattern, right, is a stellar pattern where you will see a linear or circular arrangement of vascular bundles. Notice, parehong may piece. Parehong may piece and cortex. This is the piece. That's the piece. There's the cortex. This is the cortex. Parehong may piece and cortex area ang Siphoning still and U-still stellar arrangement ng stem. However, the U-still arrangement, right, has vascular bundles, okay, and not a full ring, okay, and not a full ring, right, ng vascular tissue, right? So there are separate vascular bundles, clear vascular bundles that can be seen, right, sa U-still, but it is highly arranged, highly organized, rather, yung kanyang arrangement. Okay, so nakaayos siya in a cylindrical manner, forming the vascular cylinder, right? So when it comes to atactostele, the main difference of eustele versus atactostele stellar pattern is atactostele has vascular bundles arranged randomly, or in more simpler terms, vascular bundles that are scattered randomly. No, there's no arrangement, unlike eustele stellar pattern where there is a very clear cylindrical type of arrangement of the vascular bundles. Atactostele stellar pattern has vascular bundles scattered randomly, right, in the ground tissue of the stem. Okay, so this is mostly characteristic of dicot plants, and this one is characteristic of monocot plants. And this is when it comes to stem stellar pattern. Okay, so that's that for the stellar pattern. Okay, I hope it's clear. All right, so balikan lang natin. So you have the primary vascular tissues, you have xylem phloem arising from the procambium. You have the xylem maturation or the formation of xylem following endark, right? Or the centrifugal manner. Protoxylem first and then metaxylem next. Protoploem first and then metaploem next to the outside. Okay, and then the residual cambium was already introduced, and we will give emphasis on that more pagdating natin sa secondary growth, and of course the stellar pattern, which you can actually see in this slide. Okay, now pagdating natin sa secondary state of growth, right? So we have now the residual cambium. Residual cambium, as was mentioned earlier, is actually that very tissue, the same tissue, in the same area where you can find the procambium, but it is slowly transforming into what we call the fascicular cambium. Ano ba si fascicular cambium? Fascicular cambium, right, will eventually be giving rise to the vascular cambium. Okay? The fascicular cambium is just a part of the vascular cambium. Before ma-form yung vascular cambium, which basically gives rise to secondary xylem and secondary phloem, yung procambium will change slowly into a residual cambium and then a fascicular cambium. Okay? Now, in the secondary state of growth, right, ng plants, normally we will find pith parenchyma. Okay? So pith parenchyma would be the pith cells that are getting pushed in because of the formation of secondary xylem. Okay? So yung pith parenchyma, right, are also, some parts of the pith parenchyma will also differentiate. Okay? Later on, ipapakita ko kung nasan ito. And then they will start to form so dating pith parenchyma sila, meaning mature sila, mayroon silang sariling function as a parenchyma, a pith parenchyma. Then they will differentiate, mawawala yung differentiation nila, mawawala yung function nila. Magiging meristematic sila in nature. And then they will give rise to the interfascicular cambium. Now, the fascicular cambium plus the interfascicular cambium will now give rise to your vascular cambium. And the vascular cambium basically gives rise to the secondary xylem and secondary phloem. Okay? So mamaya, pag meron na tayong figure, uulitin ko ulit yan. Alright. So here, burahin muna natin yan. Okay. So dun sa initial na ipinakita nating dicot stem, no, you will notice na meron tayong vascular, we have the vascular bundle, okay? Where we have xylem here and phloem over there. And this is basically, this area is your procambium. Okay? Now, that area, the area of the procambium, as it changes to become fascicular cambium, nagiging residual cambium muna siya. Okay? Residual cambium. And then residual cambium will basically give rise to the fascicular cambium. So the fascicular cambium will also be found in the same area. Pero nagiging fascicular cambium lang yan if the plant is starting to undergo secondary state of growth. Now, this is the pith. Okay, so this area is the pith. And there are pith parenchyma over here, right? In between the fascicular cambium, no? Before pa magkaroon ng fascicular cambium, pith parenchyma pa lang sila. As fascicular cambium is being formed, this pith parenchyma also starts to differentiate. Okay, nakaharang pala yung picture ko. Okay, so this fascicular as fascicular cambium is being formed, this pith parenchyma starts to differentiate. So nawawala yung kanilang maturity, nagiging meristematic cells ulit sila. And these meristematic cells will now give rise to, so magiging meristematic cells yan, nagiging meristematic cells yan, yung nandyan, right? And they will become what we call the interfascicular cambium. The interfascicular cambium and the now formed fascicular cambium here, right? So, di ba, nandyan yung dating procambium natin, tapos naging residual cambium, and then it gave rise to the fascicular cambium, right? So, these two will eventually fuse together. The interfascicular cambium plus the fascicular cambium, they will eventually fuse, okay? So, mag-fuse together sila, and that will cause giving rise to a continuous cambia, right? To a continuous layer of meristematic tissue, and this is now what we call the vascular cambium. Pag may vascular cambium ka na, the plant is now ready to give rise to secondary xylem and secondary phloem. Okay? And yun, yung makikita natin dito sa picture underneath this one. Yan. So dito, meron na tayong vascular cambium. Okay? So we now have the vascular cambium here, and you will notice that you can no longer see vascular bundles. There are no more bundles. Everything is in a ring form. Okay? So itong area na to, that very delineation of cells over here, nandyan yung vascular cambium nyo. Saan nanggaling si vascular cambium? Nanggaling siya sa fascicular plus nag-fuse na, erase muna natin siya. Okay? So nanggaling siya sa fascicular plus fused na interfascicular cambium. It now formed this continuous layer, okay, of cambium, which we call the vascular cambium. Now, that vascular cambium will give rise to the secondary xylem and the secondary phloem. Notice here that the secondary xylem is termed the wood because it is indeed the secondary xylem that forms the wood of the plant. Okay, so wood, by botanical terms, wood is actually part of the stem. Okay? So, di ba tayo pag sabing wood, parang kung ano man yung mapulot mong wood dyan, ganon. Right? Pero botanically speaking, it is actually part of the stem of a plant with secondary growth, or yung mga tinatawag natin na woody plants. Okay, so you notice that we still have a pith here. Itong pith na to eventually mawawala yan. No? So you know that this particular slide is representing a plant that is undergoing secondary growth, pero bata pa siya. It is still young. Why? Because there is still pith present. Eventually, as the plant grows, it will produce more secondary xylem, and it will push the pith and makakrush yung mga pith cells until there's no more parenchyma, no? Pith parenchyma present. So there will be no more cells. Everything would be just xylem cells hanggang sa loob. Okay? So, that's how secondary growth basically happens. And because secondary growth happens, at nagkakaroon tayo ng formation ng secondary xylem and secondary phloem, So nagkakaroon tayo ngayon ng formation ng wood and then ng bark. Okay? And along with that, nagkakaroon ng formation ng tinatawag na growth or annual rings. Growth or annual rings are actually basically xylem layers, secondary xylem layers that were formed in one particular year, no, of a plant growth. So, an annual ring, kaya siya annual kasi yearly na-form yung ring. So, sa isang buong taon, isang layer lang ng secondary xylem ang sino-form ng woody plants. So, ibig sabihin, as year passes by, bawat isang year na dumaan, mayroong formation ng isang ring ng xylem. No? Kaya tinawag na growth ring or annual ring because you can tell how old a plant is. For example, you cut a tree and then you look into the stem, you can tell how old it is by looking at how or counting how many growth rings there are. Okay? So if there are like 100 growth rings, then your plant is actually 100 years old. Your tree is basically 100 years old. Okay? So growth rings tells you the age of a tree because growth ring formation or this layer of secondary xylem is formed all throughout the year. No, one ring is formed all throughout a year. Right? So the next ring that will be formed the next year. So it tells you that a year has passed if you find one growth ring, no, sa isang trunk, right, ng plant with secondary growth. Now, sometimes, kapag medyo stressful or harsh ang environmental condition, this facilitates formation of 2 growth rings in 1 year, no? And this is what we call false annual rings, right? It is normally determined by the size of the growth rings. So medyo mas maliit yung dalawang growth rings na na-form, but normally, most of the time, it's a little difficult to actually say that that is a different growth ring. Kasi habang napupush yung mga growth ring, nagiging mas maliit talaga sila, no? Because some cells are crushed along the way. Okay, now, this is how growth rings look like. So this is one growth ring, this is another, that's another. This is a 4-year-old tree. So I'm 4-year-old, tree. So bata pa siya. Okay, 4-year-old woody plant. So bata pa siya. And of course, the presence of the piece there also tells you that it's still young. So growth rings are layers of secondary, right, xylem, secondary xylem. So once again, there's your vascular bundle. This would be your xylem. These red ones are your phloem, right? Right. So the rest of the blue ones are actually cork parenchyma. Okay, so I will tell you later about that. Susunod na slide, right? So for now, you will see the growth rings here. Yan. So these are actually xylem, right? Xylem, secondary xylem layers. Okay. Now, because secondary growth basically facilitates production of wood, so there are different types of wood that are actually formed as well. Okay, so meron tayong tinatawag na early wood or the spring wood. So as the name suggests, it is formed during during the growing season. So they have larger cells, okay, and they are bigger, no, pagka nakita niyo sila. And then we have the late wood. These are the ones that are formed during late during the growing season, and they are smaller and darker. Wait, let's see if I have. Okay, wala. So balikan natin yung picture. Oh. Right. So here you will see. Okay, so here you will see the early wood and then the late wood, right? Early wood and then the late wood. Early in the growing season, napo-form yung mga early wood, so napupush sila paloob, right? Kasi sila yung unang layer na mapo-form. And then as the season, no, so ito as the season ends, nandito yung mga last mo na napo-form na cells. So they are smaller ones and they are more dense. So they are darker. So these are the early woods, yung mga malalaki, mas malalaking cells, no? Yan, early wood, this. And yung mga mas darker and mas smaller, sila yung late wood, okay? Or yung tinatawag natin na summer wood. Okay, so balikan natin yung slide. So when it comes to the wood, yung secondary xylem layer, right? So we have different wood types. You have early wood produced early during the growing season, so larger. So makikita mo mas mababa sila or mas nasa loob sila within the layer, okay? And then you have the late wood, right? So during the later part of the season, they are produced. Therefore, sila yung mas malapit sa vascular cambium. And they are smaller and darker. Now, aside from the early wood and the late wood, there are also characterization on the sap wood and the heartwood. The heartwood is basically the innermost part of the wood. No? So, diba, napansin nyo may mga growth rings, and then papalit sila ng papaliit. So the very first growth ring that was formed is actually pushed towards the inside, and then the pith parenchyma will be crushed, and then eventually the cells that will remain in the center, right, in the center of the wood, right, in the center of the xylem layers, sa pinakagitna nun, ang matitira na lang would be xylem cells. The xylem cells that are there dead in the center will lose their conducting function, and then they will be they will have deposition. So magkakaroon ng deposition of tannins, okay, tannins, right? And this will make them darker, right? So yung nandun sa pinaka-center, kaya pag nakakita kayo ng mga table, wooden table made up of the actual wood, yung hindi siya pre-process, no? Hindi siya pre-process, makikita nyo yung growth rings, and then sa pinakagitna, sobrang dark, no? Sobrang dark ng area. And that's what we call the heartwood. The heartwood have deposition of tannin. Okay? Putahin lang natin. Para mas maganda siya tingnan. Okay? Magkakaroon siya ng deposition ng tannins. And tannins are actually brown, dark brown in color. So nagkakaroon ng very, very dark color yung heartwood, and they do not have conducting functions. Hindi na nagko-conduct yung xylem nila ng water. Rather, they function na lang mostly for rigidity of or support, no? Rigidity of the stem or the trunk, and support for the tree. Okay? Heartwood are also termed hardwood kasi they are very hard na in nature because they lost all the conducting functions nila. So they have less water as well. And then we have sapwood. Sapwood naman are the ones that are mostly nasa outside. They are bigger. Sapwood are the ones nearer the vascular cambium. No? If heartwood is the one that is dead center, so meron kang cylinder, there's one dead center. Sapwood are the ones near the vascular cambium. Okay? And sapwood is very good pa din in terms of conducting functions, and they have more water. Therefore, they are softer than hardwood or heartwood. Kaya minsan, tinatawag din silang softwood. Okay, and then they can be found in the same, stem. All right. So that's another classification. Now, aside from this, mayroon din tayong tinatawag na reaction wood. Reaction wood has two different types. Okay, we have tension wood and compression wood. Tension wood, as the name suggests, it helps the plant, right, basically survive, stressful conditions, right? So tension wood is a type of wood, okay, that is commonly produced at the upper branch of the dicot or woody dicot branches, no? So this is produced in the upper side of tension wood tayo of the branch. Okay. All right. So the growth rings in tension wood are actually produced in an eccentric manner in such a way that the vascular tissues are bigger. The cells of the vascular tissues are bigger in the upper portion of the branch. So it helps the branch survive tension, no? It produce tension rather. So the branch is not too brittle, no? Kaya mga branches medyo pwede mong paglaruan and they stick until sway. Yan, it's because of the tension wood. Now, compression wood is another type. Burahin muna natin. Compression wood is another type of reaction wood. Okay? However, unlike the tension wood, compression wood is formed under. Okay? So they are formed on the underside of branches. Okay. So they are formed on the underside of the branches. Both these reaction woods are required so that environmental stress, right? So that the plant or the branches can actually resist or can survive, no, environmental stresses. So pwede silang malakas ang hangin and nagsusflail lang yung mga branches, hindi sila agad napuputol because they are not too brittle. So that's what reaction woods are for. Okay, so that's that for the secondary state of growth. Pero nandun pa lang tayo sa wood part. Kung maalala ninyo yung ating picture, right? Babalikan natin yun, huwag kayong matense. Okay, so yung ating picture consists of the inside part, kanina ang diniscuss lang natin would be the wood, no? The xylem, right? The annual rings, right? Yung sap wood, which is near here, and then magkakaroon ka dito ng formation ng heartwood eventually, and of course the tension wood, the softwood, and the hardwood, and early wood, and then the spring, no, and then the summer wood, which is the late wood. Okay, so ang pinag-usapan pa lang natin in terms of secondary growth would be the inside part, right? No, sa inside pa lang tayo. Wala pa tayo dun sa outside. So if the secondary xylem consists the wood, the primary phloem naman, along with the rest of the tissues that can be found outside of the vascular cambium, it consists naman the bark. So basically, kapag tinignan mo yung trunk ng tree or a stem of a plant with secondary growth, from the outside, you have the bark, then the vascular cambium, then the wood. That's how it is. So diniscuss natin yung wood, alam na natin kung paano na-form. So diniscuss natin yung wood, right? Na-discuss na siya, alam na natin yung attributes na. And then we know how the vascular cambium is formed, no? From the procambium into fascicular cambium, and then the differentiation of P parenchyma into interfascicular, tapos nag-fuse yung dalawa, and that's how vascular cambium are formed. Now it's time to discuss this part of the stem, which is what we call in layman's term as the bark. Okay, so that particular part of the stem is in general known as the periderm. Okay, the periderm is made up of three components. You have the phloem, which is also known as the cork. This is from the outside. You have the phelogen, which is the cork cambium. No, it's also a meristematic layer that gives rise to the cork, the outermost layer ng bark. And then the pheloderm, which is the cork parenchyma. And these are the cells that you will see interspersed in between the phloem, no, layers that you will see later. Okay, now the periderm is basically this, right, part. Yan. So nasaan yung secondary phloem? This is the secondary phloem. Yung mga red. The blue ones are the cork parenchyma. This is a very, very, very dark layer over here would be your cork. And then the blue layer na nandito between the cork and the xylem, that would be your cork cambium. Okay? So yun yung part ng periderm. Okay? Now, the periderm, sa pinakalabas, normally, dito, sa pinakalabas na layer, di ba pag tumingin kayo sa bark, yung outermost part, makikita nyo parang may mga butas-butas siya from the outside. Now, those parang breaks no? Tissue, broken tissue na nakikita nyo from the outside are called lenticels. Lenticels are formed from lenticel cellogen, right? Lenticel cellogen is basically a cambium. Okay, it is a cork cambium. So lenticels are basically formed, made up of spherical cells, and they form intercellular spaces. Okay, so pag nakita nyo sila from the outside, so if these are the cork cells, no, sa labas ng picture ko. These are cork cells. May makikita kayong mga spherical cells, right? Looking like this. And these are lenticels. No? They're not stomata. They are lenticels. Okay? So these lenticels actually gives rise to
and they form these intercellular spaces. Okay, so itong intercellular spaces na to, yeah, it facilitates a movement of air, basically. Okay, actually, mayroon pang mga cells. Hindi siya buong-buo na sira. Basically, looks like this. Yeah. Pag nakita niyo siya under the microscope, it kind of looks like that. So these are lenticels. Okay? So they have intercellular spaces, and these are actually filled with air. Okay? So filling tissues are just normally loose tissues formed in the lenticels. So may makikita kayong mga sometimes, right? Oops. May makikita kayong mga tissues in broken lenticels, and they are the filling tissues. Okay, so makikita nyo to sa lab. Hopefully, ma-supplement ng lab. Kasi sa ngayon, hindi nyo siya mapipicture dahil mahirap makakita ng lenticel doon sa ating slide dahil masyado siyang maliit. So you have to zoom in doon sa cork or the outermost layer of the bark para makita nyo yung lenticels. Okay, but for now, these are the attributes of lenticels that you have to remember. And then, of course, the periderm, we have to classify yung bark area. Kung may wood area, then may bark area. So the bark consists of an outer and an inner bark. This is the tissue located outside the vascular cambium. Sinabi ko na yun kanina. So you have the wood, the vascular cambium, then you have the bark. And since right after the vascular cambium, towards the outside of the stem, you will see the phloem, then the phloem is actually part of the bark. Unlike the wood, which is mainly made up of secondary xylem, the bark is not mainly made up of just secondary phloem. No? The bark is made up of the periderm and the phloem, the secondary phloem at that. So the inner bark is made up of, as you can see here, the secondary phloem. Okay? So the secondary phloem, the cortex, and the phelloderm. Yung phelloderm? Yung phelloderm ay yung ating cork parenchyma. Okay? And then the outer bark is made up of the phloem, which is the cork, and the phellogen. So, lagay natin. And phellogen. Phellogen is the cork cambium. Okay? So dito sa next slide natin, you will notice that. Let's zoom it in. Okay. Okay. Oops. Much. All right. So here you can see the secondary xylem. It's this red part over here. Yan. That plus the cortex, no? Plus the cork parenchyma over here, right? That would consist, yan. So lahat na yan. Tapos yung mga cork parenchyma here, cortical cells over here. Lahat na yan consists your inner bark. The outer bark consists of the cork cambium, which is this blue area over here. Yan. And this dark area over here, which is the cork. So that would be, right, your inner bark and outer bark. And in general, this is just the bark, the area outside the vascular cambium. Okay. So now you know more about plants, plant tissues, right? Or the anatomy of plant. All of this will be given emphasis pag nag-botany 119 kayo, or kung dahil na kayo with botany 119, most likely you are more familiar with all of this by now. Okay. So basically that's that for the different plant parts that we will see in terms of the internal structure of the plant. Now this is an extra slide that I put here so that you will see the fate, no, the fate of the tissues, right, or the cells, right? So from the apical meristem, ano magiging fate nila, kung sila ay naging protoderm, ano yung magiging derivative nila eventually, right? Saan ang gagaling yung court, yung periderm, yung core cambium, and so on and so forth. So this is just a diagram that shows us the fate of the tissue, right? You will also see here which tissues are involved sa primary growth and which tissues are involved sa secondary growth. Okay, so this is what this slide is for. All right, now in terms of function, the stem mainly functions for, well, support, but of course, hindi natin pwedeng alisin that the stem is the main area for transport or conduction. And this happens for both transport of water and dissolved minerals, and of course yung organic compounds that are produced during photosynthesis, or yung tinatawag natin na food. Okay, so when it comes to xylem transport, there are two types of transport, or two ways kung saan water, because xylem basically transports water and dissolved minerals. So alam na natin yan, no? So, para ma-translocate ang water and dissolved minerals all throughout the plant body, right, we are guided by two different theories, right, or two different ideas on how water is actually translocated. So we have the adhesion-cohesion theory, where it says that water, no, adheres to the walls of the stem, right, or the xylem cell, and they have cohesion with one another. So the reason why the tout water column does not have a backflow, no? So water is absorbed from the root, and then without any pressure coming from the top, water is actually conducted pataas and against gravity. Right? This is one of the wonders, right, of biology at that, not just plant life. How come water can be translocated through xylem upwards against gravity without any suction pressure on top? This is because, according to two different ideas, no? So one of them tells us that hindi bumabalik yung water, hindi siya nalalaglag, hindi nagkakaroon ng backflow because of this adhesion-cohesion theory, wherein it is said that, right, the xylem cell, right, has this interaction with water, right, molecule, and nagkakaroon ng adhesion between the xylem walls and the water molecule. And since water molecule ay nagkakaroon ng interaction, ng cohesion between two water molecules, right, so nahahatak ngayon ng isang water molecule, yung susunod na water molecule at yung susunod na water molecule, at ito yung nagiging reason kung ba't nagkakaroon ng tout ng water column. Okay? And the reason why hindi siya bumabagsak is because they are actually adhered to the walls of the xylem. Okay? So the whole translocation of water through the xylem is guided by this idea. Another idea that guides this would be root pressure, wherein ang kwento lang yan is simple. Xylem from the root is, of course, continuous with xylem in the stem. So once water is absorbed in the xylem of the root, right, it is pushed, no? Pushed by the root pressure paakyat. Ano yung root pressure? You know that the root has a Casparian strip, where this strip is highly thick, and pag nakapasok na yung water in that area of the root, hindi na siya pwedeng lumabas. So, yung absorption ng water is dire-diretso paloob, right? And this now creates pressure inside the root, and this now pushes water back out. And the reason why there's no backflow is because there is a mechanism of actually preventing backflow and creating pressure around the wood, right? And that facilitates the whole xylem transfer. Okay? And then, of course, we have the phloem transport. This is guided naman by the pressure flow hypothesis. The pressure flow hypothesis is simple. Kaya siya naging pressure flow is because the flow of materials follows difference in uh, um, gradient or pressure gradient. Okay? This time naman, we have what we call the sink to source movement, no, or flow, kung saan the sink has higher, right? It has higher concentration of solutes, right? And the source has lower concentration of solute. Kasi ang tinatranslocate natin sa phloem ay solute. Okay? So the sink has higher concentration of solute, the source has lower concentration of solute, therefore there is a pressure that pushes the movement of solute, no, from a higher gradient to a low concentration gradient. So the higher concentration gradient of solute creates the movement. That is the pressure that creates the flow. Kaya siya tinawag na pressure flow hypothesis. So sa sink, laging mas mataas ang solute at kailangan siyang i-distribute sa source where the solute is actually lacking. And that is how flow and transport basically happens. Okay. So that's transport as the first function of the stem. And then, of course, we have support, right? So the stem contains mechanical tissues such as your collenchyma and sclerenchyma, rather, not parenchyma, collenchyma and sclerenchyma tissue, right? So here we just give you attributes of collenchyma, right, which are usually subepidermal. It helps retain the shape of the stem and maybe continuous, right, or continuous or in patches, rather, continuous or in patches. Okay, and then of course we have sclerenchyma, the one that is most sturdy in terms of the tissues, right? And they are normally scattered amongst the cortical or root cells. And that is how support is actually done, right, by the stem because of the presence of these tissues. Of course, the stem can also function for storage, pero only specialized. Let us take note of that. Only specialized stems, right, form storage tissues. Example of that will be tuber, and that would be introduced to you guys later towards the end of the lecture, which is malapit na. Okay, doon sa ating mga modified stem. Okay, storage, by the way, storage within the stem can be found in parenchyma cells and collenchyma cells since they are the ones with a living protoplast. Okay, and of course, stem can also function in terms of tropism. Tropism is the response of a plant towards an external stimuli. Okay, and normally tropism are directional response. Okay, so we have phototropism kung saan the plant follows the area where there is more light. No, negative gravitropism, this is because the plant grows, the stem grows basically against gravity such that it grows upwards, no? And of course, stigmotropism, which means the plant responding to touch. Okay, we're not going to dwell into the physiology of each. Okay, and last in our discussion would be the specialized types of stem. Now, there are different types of specialized stem, and you will see some examples of this given in the slides, okay? And also the attributes that basically characterize the stem. So first, we have rhizome. Rhizome are horizontal underground stem that may or may not be fleshy in nature. They have the ability to produce new plants in the regions of their node. So a very good example of rhizomes would be ginger, right? Or turmeric, like that. Yeah, makita nyo. And here I am showing you, right, how rhizomes are giving rise to new plants, right, at the region of their node. roots. Ayan. Okay, so here as well. Ayan, so new plants will arise from these modified stems, right? And they are horizontal in nature and they may or may not be fleshy. So basically, yung ginger na ginagamit nyo pang luto is actually not a root, right? Even if it is underground, it is actually a stem. Okay? And then we have tubers. All right, so tubers are fleshy underground stems or rhizomes, as we call them, but they are highly enlarged to store food. So basically, tubers are enlarged rhizomes. Okay, the abundance of food in this stem allows it to grow into a whole new plant if you separate it, right, from the original plant. Oh, sorry. If you separate it from the original, ano ba yan? Naduling na si Ma'am. Plant. Okay. Right? So, now that gives you the idea na unlike carrot, which is a root, kamote and potato are actually stems. Okay? They are tubers. All right. Next, we have stolons or runners. So, ito yung mga ito, horizontal, right? Growing stems. But unlike rhizomes, stolons are actually located above ground. Rhizomes kasi can be found below ground. Okay, so stolons can be found above ground. And they exhibit very long internode. Okay, and then they develop buds, right, that will eventually give rise to new plants. So in our example, in this photo, this is actually a strawberry. Right? So new plants of a strawberry is arising from this horizontal stem, right? And they become connected to one another. Another example na mapapansin nyo na mayroong stolons would be grasses, right? Kaya minsan pag nagbubunot kayo ng damo, right? Once binunot mo yung isang clump ng grass, parang mayroon siyang connection to the next clump of grass. And then pag binunot mo yung may connection, those are actually stolons, all right, or runners as we call them. Then we have tendrils, right? So tendrils are lateral branches that twines around small objects, and their function is mostly for support. Okay, so ito yung mga normally nakikita natin sa vine. So and these are examples of tendrils. And then we have corms. Corms are very short. And this time, it's not horizontal. They are vertical stem, and they are covered with papery leaves. Okay, they are used for storage of food. And the main storage tissue is the stem itself. Corms sometimes are, in layman's gardening terms, corms falls under the classification buds, no? Buds. But buds are actually different from corms. The main difference, oh sorry, not buds, bulbs. Bulbs. The main difference between bulbs and corms is the way they store, no material. The main storage of corms would be in their stem. The stem itself. Dito mismo. Okay? At hindi ka makakakita ng layers, no? Of like leaf-like layers dyan. Isang buong, the way you see this, ito, ganyan, right? Itong nakikita nyo, na parang solid storage tissue, right? Yung nakikita nyo dyan. Ganyan yung itsura sa loob ng corm. Maputi siya most of the time. This is gladiola, by the way, or gladiolus. Right? This example. Kaya nilagay ko yung flower para makita nyo yung sample plant natin. This is the corm or the stem, modified stem of gladiolus. Alright? So the difference between bulb and corm, even if they look alike, so this is onion naman, as you can see here, is the main storage tissue of bulbs would be their modified leaf. So makikita nyo dito, yan ay mga leaf. Right? So these are modified leaves of the bulbs. Okay, so they are compressed, they are also underground, and they are sometimes called basal plate. Okay, they have modified flower bud, right? Or other growth point that is surrounded by modified fleshy leaf. Right, so ito yung kanilang modified bud. This is their modified leaf. And their main storage is the modified leaf. And that's the main difference between a bulb and the corm. No? Although, kapag general lang yan, hindi botanical term ang tawag sa mga yan bulb kasi mukha silang bulb. Right? But corm and bulbs are actually different if we're pertaining to botanically speaking, strictly botanically speaking at that. Okay? And then next, we have, so that is basically the last specialized stem that we have. All right, and that concludes our lecture for the organ and organ system in terms of the shoot system. This is our discussion for the stems. Now, if you have any questions, you may ask your designated professors about that. I hope you learned something. I hope you learned a lot, or something, if not a lot. And I hope you learned something, okay, that will make you appreciate botany a bit better. So the next lecture will be on still the shoot system, but it would be on the leaf as an organ. Okay, so I will see you in the next video lecture. Bye.